types of analysis. So while designing a structure, we need different type of analysis. So mainly we encounter three type of analysis for the design of structure. The first one is static analysis. In case of static analysis, we determine the internal forces like shear force and bending moments. So to perform the static analysis, we need loading conditions and the boundary condition. We need the loads as well as the boundary conditions. We don't need any material or section properties. For example, while analyzing a beam, simply supported beam, we just consider that we draw a line diagram and apply the load that it is a beam subjected to uniformly distributed load, and we calculate shear force and bending moment diagram like this. And for this calculation, we do not require any cross-sectional as well as material properties. So this is termed as static analysis. The second type of analysis that we may perform is stress analysis. For stress, so this stress analysis is performed for stresses and strain. So if we want to calculate the stress and strain inside a section or inside a structural member, so then we perform stress analysis. So it is based on the material strength, section properties and loading conditions. For example, if we have a column and it is subjected to a point load at the top, axial compressive in downward direction, and we know its dimension B and D. So in that case, we require to calculate the stress. Under the application of load P, what will be the stress in that column? So we will calculate the stress sigma is equal to P over A, or P divided by B times D. So this type of analysis is termed as stress analysis. We have calculated the stress under the application of load, or due to the application of load. The third type of analysis is capacity analysis. So if we want to calculate the resistance or capacity of a member, then we use capacity analysis. So in that case, we need material strength as well as the section properties and loading conditions. So based on these information, we calculate how much resistance this section will provide, or how much will be the capacity of that section. For example, if we have a column again, and we know its B and D mean its area, and we also know that it is a steel structure with Fy 420 megapascal. So now we have the material property as well as sectional properties. Now we need to calculate how much load it will bear. For example, this B as well as D is 10 millimeter and 10 millimeter. So P will be equal to sigma into area, or stress into area. So stress here is 420 and area is 10 by 10. So 420, or we can say 42 kilonewtons. So this member will resist 42 kilonewton load. So this is the capacity analysis. Based on the sectional properties as well as the material strength, we have calculated its maximum resistance. So while designing, we need to perform these three types of analysis most of the time.